things first, let's have a look at what actually changed in the data compared to the data set that you've been working with during the first Excel session, so session number 3. First of all, you see that in the title we have years now. And the reason why I deleted them in the first place, because I thought they're unnecessary and that we might want to work with a word count. That was a mistake. Why? Because actually, well, there is sometimes more than one movie with the same name. If I remove the year, we cannot really tell them apart anymore. You will see once we start composing pivot tables that this is actually very important, that each movie, each title has its separate row and has a unique name. That's why in this case we have years included. Building up on this, I actually did create a word count variable. This is the formula for it. So this is the original formula that you can find online. Here you see a note so you can see where I took it from, and you can check it out. It's nice to know some formulas, but for some things you can just go and Google how to do it. If you want to understand the principle behind it, just go on this link and check it out. So this is the original formula, the one that is highlighted. And why I added this -1? Exactly for the fact of this year, just so that we have a truthful word count, not just something. I subtracted -1, so exactly this year chunk. What else? Now we only have movies in our data set. If I create a table out of this, you will see that we only have movies now. And we have duration in minutes now. I already calculated it and divided it. You see that some values are missing. That is also something that will be important later on. And we have 0, which is not really 0, so I cut it down to minute counts, but actually the traffic crossing Leeds Bridge is not 0 movie. It just has a few seconds. That's why it's such a small number. So if you see 0, it's probably a very, very short movie. So this is it. Now, as usual, we are going to create a pivot table to get started. And let's see whether we don't have any replicates on the title. So we throw in title into our rows, and we can also throw in title in columns. And you see Excel suggested right away that we have counts. So let's sort it just to be sure from Z to A. Still all ones. So now, yes, all the titles are unique. So we have again in each row our participant, our respondent. In this case, this is our movie. If you use the old file, you will see that we have some replicates here, and this is exactly the movies that have the same name but were filmed in different years. And of course, you can still fix it by using a variable year, but now we don't need it because all the variables are unique. So we will be trying to predict IMDb rating. So this variable here, and let's change it from count to sum or average. It doesn't really matter because there are no zeros. Let's check by sorting it. There is a blank, however, and let's kick it out right away. We don't need any blanks. Where is our blank? Let's search for it. There's blank, but that's the name of the movie. Interesting. Let's throw in titles here and remove in the filter and remove the blanks from here. There we go. Now it's nice and clean. We don't have any missing values. That will be important when we're trying to predict the future. Linear regression does not like missing values. In general, regression functions do not like missing values. This is not only true for Excel, this is true for most programs. There are different ways how the program treats with it. In case of Excel, it will just shoot out an arrow. So we're trying to predict IMDb rating, and how do we approach this? Well, we have a bunch of variables here, long list, and we can throw them all in, not at once, or we can start by using common sense and say, okay, well, there are some factors that you might have a feeling have an influence. So let's start by checking those. For example, a duration of a movie. That might be something. And here again, let's kick out and not call it count, but sum or average doesn't matter. Again, we have some missing values here, so we have some missing records. We don't know how long some movies were. Let's try to run a linear regression. And remember, we have our dependent variable IMDb rating, and we try to find independent variables, so things that are influencing IMDb rating. For example, a duration of a movie. Here, the common sense that I would use, okay, if the movie is too short, I might feel that it's very shallow and not really finished, so that's why I might not like it. Or maybe if the movie is too long, I just got so fatigued, but I didn't like it anymore. So we are now going to our data and try to run our first linear regression. Here it is. We press the section regression, and we delete everything that we had here before, because I already played with it a little bit. And we select our IMDb rating. Oopsie, we still have our grand totals. That's not nice. Let's remove them. In the design, grand totals off. And once we added this first column A is super wide, so let's make it a little bit more narrow so that we have a better overview. So let's try it again. Data analysis and regression. Again, remove everything you had here before. Select average IMDb rating, and I'm using a shortcut Shift-Control-F to go and select the whole column. And let's do the same thing for our first independent variable, duration of a movie. And here we have a bit of a problem because Excel starts stopping if I have empty values. So that's gonna take forever. I'm just gonna speed it up and type in the last row because it should be the same manually. So we have 10,491 here. Let's make sure we have labels clicked, and we click OK. And here is the arrow that I've been telling you about. Excel doesn't like missing values in the regression, so we click OK, cancel the whole thing, and make sure we remove missing values first. So how do we do it? Again, we also throw in duration. The second time, now in the filter, click select multiple, find our blanks again, and remove them. Now we have everything clean, no blanks present. But look at that, again, this column A became really wide. It's getting annoying, and it will probably keep jumping back to it every time you drag some new variable in one of the pivot table windows. So let's try to stop this from happening. We go to Analyze, Options, and here we go. Auto fit column width on the update. Let's untick it, click OK. And we'll see in the future that then the column will stay like this and will not jump into super wide anymore. All right, so let's try to run this linear regression. We already have our regression. Let's remove everything because now our list is shorter, since we removed some of the movies where we don't know the length of. This is a trade-off. There are actually different strategies of how to deal with these missing values. Excel only has a default one. You might use different techniques to fill out these missing values instead of deleting them. But we have a huge data set. Have a look. We have still over 10,000 movies. So if we lost a few, that's not a big deal. So we take this trade-off to make our life easier. That would not always be the case, and we select X, which is our independent variable, as movie duration. We make sure the labels are still ticked, and we click OK. So here is our first regression. We created it. Let's drag it here. And whatever we have here, let's make an order before it gets really complicated. So this is an empty sheet. We delete that. This is our regression pivot, and this is our regression number 1. Only one independent variable. So the numbers look quite overwhelming. Let's brush them up a little bit so that we can actually have a look. So first of all, select the whole thing and double click so that you can actually read the headings. Now let's cut these ones down to, let's say, 3 decimal points after. And everything else here, we don't need the degrees of freedom, but these things here to 2 decimal points. These are our significances, and we find another significance here, so we throw in 3 decimal points for these ones, as everywhere else, and everything else 2 decimal points. So as you see, I select multiple fields at a time. When I'm doing it, I select a field, and then I press Ctrl and select another field. Then I can right click and do that quick at 2 decimal points after. Okay, so that looks much more digestible. What are we actually looking at? So first of all, regression is a complicated analysis. That already sounds really painful. We have to drag in all the things. We have to think what variables are predicting something and throw in stuff and so on and so forth. So it's important to be sure that actually it makes sense to go through all this trouble. Remember, the simplest way to predict whatever is going on is the mean. So what we could do is just say, okay, so what's the mean of IMDb rating? We see, if you highlight the whole column, you see it here in the corner. The average IMDb rating in our data set is 6.7. So if I only know this and I had to make a guess for any movie, you tell me a movie, I know nothing about it, and I need to guess how high is the rating, I probably should say 6.7. Then you start giving me additional information. Let's say, how long is the movie? Is this information useful to improve my prediction, to improve my guess, or not? Should we go through this trouble of accounting for duration of the movie to predict it or not? This is the first question you should ask yourself. Should you go through all this trouble? And the answer is right here in this ANOVA table. This significance value, it tells us whether we should go through all this trouble. It basically tells us that if we include duration in minutes into our model to help us predict the average rating, our prediction, our guess, will be significantly better than just taking the mean. So the simplest way, simplest approach possible. And here it's significant, so it tells us, yes, it's worth going through all this trouble. It's worth running a linear regression. It should be a better prediction. This is the first thing to look at. The second thing to look at, especially afterwards when you will have multiple predictors here, multiple things predicting one, is to see whether actually this particular item that we're including is significant. And it is. So we can keep it. And then, well, but how much actually, we created now a rather simple model. How much does this model explain? Then we jump into the upper table and we see we're interested in these two scores, R-square and adjusted R-square. What is the difference? An R-square, which is 3% by the way, so this 0.033 is 3%, and it tells us how much this model, this thing that we created here, actually explains from our data. But in reality, we don't care of predicting our data. That would be nice if we have all the data about something in the world, all the movies. We, however, only have a sample, and we want to predict the reality and not what's going on in the sample. For this, we have an adjusted R-square. Here it's the same in some cases, in many cases it will be different. So what our adjusted R-square tells us is how much of the reality in the entire world of the movies, how much of the IMDb rating score can we explain by the movie duration. Again, 3%. That's not much. I have to break it to you, if you work with real data, you can never explain 100% of your data or of the entire world. But you can try to get it as high as possible. And quite often it will be rather low, but 3% is really, we can do better. We have still a lot of data that we might potentially include. What else is relevant for this table? So first of all, the coefficient. Okay, now we've found out that duration of the movie has a significant influence on our dependent variable, IMDb rating. But in what way? By how much? To know this, we jump and look at this coefficient here. What does it tell us? First of all, we look at the sign of the coefficient. If there is no minus, it means it's positive. Therefore, the longer the movie, the higher is the IMDb rating. But by how much? What's the strength? So here you will realize that it's very similar to how we treat the correlation coefficient R. It's kind of the same principle. We also orient on the sign, and we also can more or less tell by how much. How we interpret this here, we say an increase of duration of a movie by a unit of measure, which is minutes. We already know it's minutes. So if I increase a duration of a movie by 1 minute, by how much will IMDb rating increase? IMDb rating will increase by 0.01. So if my movie 1 minute longer, the rating probably will be 0.01 higher. So let's say if I have a movie that is 100 minutes, and then I think, oh, maybe I can add 1 extra minute of some specials or some other scene. If I create a movie of 101 minute, this one, if this IMDb rating here will be, let's say, 6.7, this is our average, then this movie with a length of 0.01 will have IMDb rating of 6.7 plus this coefficient here. So this is how more or less it works. We will get to how to calculate the entire prediction in a little bit, but for now, remember, first we look whether it makes sense to go into all this trouble. Is this value in the ANOVA table significant? Yes. Are the coefficients that are the independent variables that we included actually make sense? Are they significant? Looks like yes. What is the strength, the magnitude of these coefficients? In what direction are they influencing? And then we look, how good is our model? How much does it explain from our data? This is R square. And of the entire universe of IMDb ratings. This is our adjusted R square. So now let's try to make a more complicated model. There are many more variables that we have. Let's throw them all in. Let's take our shopping list here. This is a list of our variables and see what we could throw in into our model. Okay, the duration of the movie seems to be important. Maybe also number of wins, number of nominations, number of news articles, or maybe genre has an influence, and so on and so forth. You can go on and think what you will throw in. Before you do that, there are a couple of things you need to consider. First of all, we're considering different components that might influence IMDb rating. We need to make sure that these components are unrelated between each other. So we cannot accept a high correlation between components. And why is that? Because if the correlation between the two components, the two independent variables that we include in the model, is very high, then basically we're including the same thing twice, and we shouldn't do that. That's why before we jump in and start throwing all these variables that seem to, by using common sense, for us seem to might have an influence on IMDb rating, let's check whether they actually have a strong correlation, which variables we should not include together. So what variables do make sense? Let's say number of wins. Let's extend this window a little bit. Number of wins, let's change it to a sum. Now this window is too small. It's a tough game. Number of nominations. Number of news articles, number of user reviews, and number of genre. All the other variables except the word count. Let's throw in the word count as well. So now I think we threw in all the continuous variables except the year. We'll roll back to the year in a second. We threw in all continuous variables, so we need to correct this count into, because it shows us counts, which is not good. We're working with continuous variables. Let's throw in the sum. How do we do that? This is getting really complicated and tight in this little window here. Doesn't matter. Everything on the right click, and we step on the variable. We right click, variable settings, and we go with the same. We take the sum and we correct each from count to sum if Excel told us automatically to do the sum. That's much better. So now let's run a correlation to see which variables we should not include together, which of them are basically the same thing. And we don't want to include the same thing, the same independent variable, more or less twice. So let's run a correlation. In our data, correlation, let's delete everything that we have here. And as you might see, I am not including IMDb rating here because we don't care how much these things correlate with IMDb rating. They probably do, they should, and regression will tell us if they are. But we interested in the correlation of variables that we might consider as our independent variables. So let's do a shortcut. Select all of these variables and Shift Control press down. Make sure labels are included, click OK, and let's have a look. Well, this is again a lot of overwhelming things. Let's order it. Have our correlation. Select all of them to see the names clearly and make it a little bit nicer. 2 decimal points after comma will do just fine for our purposes right now. And what will be the cutoff point? So generally there is a different technique, a more complex technique to find out which variables do not belong together in one model. We will use a shortcut which is most of the time just as effective. And we will use a rule of thumb which will tell us whether the correlation is about 30-40% or higher. These two variables should not come together in one model. They're too close together, and it's very likely that we're kind of including something twice. But this is, again, an overwhelming number of numbers. So you might screen one by one, or you might get a little bit of help. I'm going to get a little bit of help. I'm selecting all of this, and I'm going to format my data. So I go to a home button and select conditional formatting and look at that, what's happening. So now Excel looks at the numbers and based on that colored them nicely. So this seems like a good idea. We do not want high numbers, we do not want high correlations, so I pick this one, and it already tells me that Logically, number of wins and number of nominations are highly correlated. So these two are definitely not coming together in one model. So is number of news articles and number of wins. Kind of makes sense because if you win more awards, probably you get a better news coverage. Number of nominations and number of news articles, the same story. They're probably different awards that are being highlighted and by different media. So if you're nominated, you get mentioned there. Number of user reviewers should not come together with number of wins and number of nominations. This we already looked at. So this is something to keep in mind, and we will start shopping for the new variables to include. We will be careful to do that, and we'll jump back and forth to refer to this table. As you see now, for the correlation, for the regression story, I am only interested in the correlation coefficient, so I'm not going to calculate the significance, the p-value for this one. I am interested only in the R, in the Pearson R. So, what I put a pin on and would like to roll back to is one continuous variable that I left out. That is year. Year seems like a good, reasonable variable to include that, but there is another assumption, another rule for the regression to keep in mind. I do not want to go too much into detail with this because it's getting a little bit advanced already, but I will just give you a quick preview. So if we go to the original data, all the statistics that we've been working with so far, most of the time, or almost all the time, assumes normal distribution. You read at the beginning of this course what normal distribution is in your literature reads, and you know that it should be a nice bell-shaped curve. So what you can do is to explore the data. Let's explore IMDb rating, our dependent variable. That definitely should have a normal distribution if we play with the linear regression function. How do I quickly have a look if it has a normal distribution or not? I might run a couple of tests, but quick and easy way is to do exploratory data visualization. So I'm going to an insert button and I'm shopping around here in the charts, and we have a histogram which will show us. Well, it's not a perfect bell shape, but it seems pretty bell-like. So we'll keep this one. Let's remove it for now. This is just for us to explore. And let's see what happens with the year. If I include the histogram for a year, well, this is nowhere close to the bell shape. And also remember, Excel doesn't know what years is. It just looks at them and thinks, whoa, huge numbers, and also very skewed. So if we throw in something like this in our regression, we might get into trouble. So that's why we are not going to do that. What happens if we do the same thing on duration? Well, it looks more or less okay. There are some short movies, probably some special segment. In general, well, this is already quite a pointy bell. Not ideal, but nothing is ideal when you work with real data, so this looks quite okay. We will also have number of wins with a lot of zeros. So this is a crime that we're going to commit. I checked and it seems like it's okay to commit this crime. This is usually, as you see, this is completely not normal distributed. This is absolutely different, and we have a huge spike at 1 and then it extends. This is not ideal to use something like this. You might think of restructuring a variable like this maybe into two, one with yes and no, did a movie win something or not, and another one with how many awards have been won. You might kick it out. But for the sake of this example, it works actually really nicely, and we can ignore this one. So I already played around with the data, so I know what hurts the most and what doesn't. The important thing is that we want to have a workable model, so we are trying to make a balance between things that work and crimes that we're committing statistically. So this is always, statistics always comes with a little bit of common sense, and the more experience you get with analyzing the data, the better. The point is that, however, if you want to run models like this yourself, you will need a different course. The importance here, why we're learning this now, is that you have a general understanding of how things like this work. And if you want to learn more, you can. And if not, you have a general principle, you have the foundation to understand if somebody else tells you and explains you the findings, and you're the one important boss who decides whether you should believe this model or not. Okay, lyrics aside, we're rolling back and let's try to make a more complicated model. Let's scroll back up. And let's use our correlation cheat sheet. So we should not use number of wins and number of nominations together, 80% correlation. So let's kick out number of nominations from our pivot table. Untick. What else? Number of news articles and number of wins. Number of news articles and number of wins. Well, still quite high. I'm just treating number of wins because that seems like a nice variable, and all the other ones are artifacts. Whether to choose number of nominations or number of wins, well, that is a decision that is rather subjective. It's important to take one. The correlation is so high that it probably doesn't matter which one you pick. But news articles probably is the result of number of wins, so we can kick this one out. This is the logic that I will use here. Number of news articles, number of user reviews also had something to do with all of this. Number of user reviews, again, probably have something to do with number of wins. People went and watched the movie after they learned that that it won something, and then wrote all those reviews. So user reviews out. How about number of genres? Looks quite clean, no high correlations here. So what do we have? Let's make it a little bit wider to see number of wins, number of genres, and the word count. So ideally, when you work with the regression, you try to throw in one variable at a time. That's gonna make this video really long. So we are going to throw all of these at once and see what happens. But ideally you do a stepwise and you throw in one variable at a time. So we started with duration. Now the next logical step would be, say, duration and win. The next logical step, minutes, win, and genre. So, but we are jumping through for the sake of time. Here's our data. Back to regression, back to building the models. Let's, just to be on the safe side, untick everything and start over. IMDb is what we're trying to predict, so this is our Y. And all the other columns that we have left here are our X's, our independent variables. Labels are clicked and we click OK, and here we have it. Rename it right away, regression number 2. Make it more readable. Adjust the formatting. I'm just going to adjust it everywhere to 2 points, and then pick where I would like to have 3 points after the comma, which is p-values. All right. Again, ANOVA, is it worth to go into all this trouble? Is it significant? Is our model better than just a simple guess of the mean? Yes, it is. Are all the variables that we included have a significant influence? Yes, they do. How much are we explaining in the data? 10%, and in the world 10%. Well, that's already better than 3% that we had before. And now we're rolling back in and we have a look here. So intercept is kind of our base. If we don't know nothing, this is our intercept. And then we start adding. Average duration in minutes, incredibly small, but here it is. Has some influence. You might have realized that it dropped a little bit because we started adding other things. That's another reason. Whenever you will start adding more coefficients, all the other coefficients will change. That's because it's not a vacuum. Some things are getting sucked out by other variables. So let's have a look. Number of wins. One additional win increases, has a positive effect on IMDb rating and increases it by zero point zero 0.03. Number of genres. One additional genre actually decreases IMDb rating by zero point zero 0.06. That's probably if you have too many genres, your movie is kind of everything and nothing, which is not a great idea. Word count. This is something about marketing. If your movie has too long of a name, that has a negative effect. One additional word in the name of your movie decreases IMDb rating by zero point zero 0.01. That's probably because it becomes more difficult to create marketing campaigns for it, or maybe it's word of mouth. If there is a really long name for a movie and people want to talk about it, they might have trouble remembering what the name actually was. Let's do one more and then you will be off on your own playing around. So we still have a bunch of things here, for example, genre and all these dummy variables. What do we do with dummy variables? These are the ones that only have yes and no. First of all, now they're recorded as zeros and ones, and we would like to keep them this way because regression will just keep it as numbers, and you will be able to interpret it by saying what it means from going to 0 to 1, from 0 to 1, which is our unit of measurement. Let's see how this happens. Let's add one genre, let's say action. And let's see what we have here. Count data, we'll need to change it to some because otherwise it's ones everywhere. Alright, that's better. But wait a second, we have action here, which is whether the genre is action or not, and we'll keep adding genres afterwards just to find out which ones actually benefit IMDb ratings and which not. And we also have number of genres here. That's not good. We learned that the variables that have a relationship between each other that kind of show similar things should never be in the model at the same time. So we should kick out the genre, the number of genre, and get into specifics and figure out which genre actually is doing what. So where are our number of genres? There they are, untick it, and there we have it. So now let's have a look what happens if we have a dummy variable, a categorical variable, and how we actually interpret it. Just to be on the safe side, starting all the selection over again. Labels are on and click OK. This is our third regression. Let's format it a bit so that it's more readable. And p-values to 3 decimal points. Alrighty, everything is still extremely significant, which is fantastic. That's not going to be the case for later on, but now we see still makes sense to go into all this trouble. Still all the variables are significant, and we already are explaining 12% of our data and 12% of the entire universe. But you see the numbers are slightly different. We have 1159 here and 1155 here. So we will be able to explain a little bit less of the reality compared to our data because we have all of our data, and that's only chunk of the reality. Rolling back here, all the variables here are significant, and this is action. How do we interpret action? We know that in our data, action is 0 or 1. We can even type it in so that we remember. And 0 means no, and 1 means yes. So whether the movie is action or not, is belonging to the genre or not. And like in all the other interpretations, what we're doing here, we're saying if we're going one step higher in our measurement, in the dummy variable, we have only one step. So if we're going from 0 to 1, how this will influence IMDb rating. We are always going higher. So if we go from 0 to 1, the IMDb rating will actually drop by 0.35. So if the movie is action, that significantly decreases the IMDb rating by 0.35. Just for comparison, the word count is in number of words. So plus one word minus 0.01. Number of wins plus one additional trophy, one additional win plus 0.03. Duration in minutes plus additional minute plus 0.004 on the rating. This is how you interpret these things. Another important thing, your task now will be to keep on kicking new variables and experimenting with things. I would suggest that you include 3-4 genre at the time and you have a look. Once you see an insignificant genre here, kick it out, remove it from the pivot table, remove it from your analysis, add a little bit more, and so on and so forth. So you go step by step, creating more and more regressions, keeping only significant values in and removing the insignificant ones until you land on the final combination. So play around with different genres. It will take a lot of time to do one by one. So maybe take 3, 4, 5 at a time. Run a regression, have a look at the p-values, remove the insignificant ones, include next batch of genres, and so on and so forth. Important thing to remember. Excel will not allow you more than 16 independent variables at the time. It's generally too much, so you might have to make a decision and settle for something less. This is your call, what to remove, maybe some things that you think are not so important or not so relevant for our data. It's your call. In this case, this is one of those situations where it's very much dependent on your common sense. Now it's your turn to play around and finish this, check out all the variables that we have and finish the model the best way you can.